Alright, welcome to 7.5, Solving Trigonometric Equations. This section should be somewhat of a relief compared to the other sections that we have. We're going to be taking our trigonometric identities. We apply them to solving algebra, which kind of might sound a little scary, but believe me, a lot of the stuff that we do here I think will start making more sense for you. We first need to review principal values, and that's when we talked about cosine being between 0 and 180, and then sine and tangent between negative 90 and 90. So the book talks about principal values. That's what they're talking about. It's nice when they do, because then you end up with one, maybe two answers at times. It's not nice when it's not principal values, because then you got to be careful that you put the k in there, and that because you can represent an infinite number of values. And somehow I lost my cursor, so give me a second. Let's see if there we go. And so in order to teach this section, really all I'm going to do is look at textbook problems. And so if you turn to page 459, you'll see number 18. In these ones, we are dealing with principal values. There's one trick that will happen in 20 that you got to be careful, but principal values of x, meaning x, and not what we get like in 20, but x has to be within that range. So when I look at cosine, my principal value of cosine for x is going to be that x is between 0 and 180 degrees. So that's the first thing from the principal values. And then now I really solve, and it's a two-step equation. Like you may remember, you started learning these in 7th grade math. But here we have cosine x plus 1, or 2 times cosine x plus 1 equals 0. So I want to solve for x. I go ahead and do that. Subtract 1 from both sides. I get cosine x equals negative 1. Divide both sides by 2. And I get cosine x equals negative 1/2. Now, if I had to, I could do the inverse of both sides here, use my calculator, and I would solve for x. I hope what you notice here is that that's a special triangle. And on all of these, please do this first. Please do your special triangles first. And so we know that the cosine of an angle using SOHCAHTOA is adjacent over hypotenuse. So to be negative 1, I have to be over here, and then I have 2 over and 2. But since I have principal values, I don't have to worry about that one. And so this is from our bow ties unit circle unit. Even though my radius of the unit circle I have as a 2, so it's not really a unit circle. But I have a 1, 2, and then if you recognize that as root 3, or if you use Pythagorean theorems, you get root 3. And then the other thing is, on just about all these problems, you want to remember your special triangles. And in our case, a 1, 2, root 3 triangle is a 30, 60, 90 degree triangle. And so this right here is 60 degrees. If that's 60 degrees, then this right here has to be 120 degrees. And so x is 120 degrees. Because x is the angle that I put in my cosine to get that ratio. A tricky problem is number 20. And so we got to remember we got principal values. Now what that means is x has to be between negative 90 and 90, because we're dealing with tangent. But this 2x really throws people off. So a lot of people get this problem wrong, and you might want to put parentheses right there, because they think that the 2x has to be between negative 90 and 90. It's just the x. Now, so let me demonstrate as we do this problem. I could add root 3 to both sides, and I got tangent 2x equals root 3. Now, if I take the inverse of both sides, and before we didn't take the inverse, but if I take the inverse of both sides, you'll see that 2x equals tangent inverse of root 3, and that would be root 3 over 1. Now, you may get to a point where anytime you see a root 3, you're thinking the 30, 60, 90, but if you don't, this is why I'm doing it this way, is just taking the inverse gets you this point. Then what you do is you look at where do I have tangent root 3 over 1. Now remember, this is opposite over adjacent, and so they're both positive, so the easy one is right here. They're both positive, and so I have root 3 over 1, but I have another place over here, and this is where it gets really tricky right here. Over here I have the possibility of negative root 3 over negative 1. And if you sit there and go, I would never know that, that's okay. This is, you know, by far the trickiest problem that we've covered, that we'll cover in this section, but I do want to show it to you. So the reason why I don't cross this out, because we know tangent has its principal values between negative 90 and 90, is because so far this angle is 2 times x. So now I don't want to go from 0, well, I'll go from 0 to here, but I don't want to go from 0 to here. I really want to go negative this direction. And we'll get to that in a minute, but so far what I have is I have 2x equals, and in this angle right here, this is a 30, 60, 90 degree angle. This angle right here has to be the 60 degrees. So I have 2x equals 60 degrees, x equals 30 degrees. So that's one answer. Well, the thing is, and which is the confusing part, is I also have this angle right here. Now this angle also is 60 degrees, but I don't want to deal with that. I want to go negative, and if I go negative, that's 90 degrees from here to here, and then to get, or let's do this, this is 180 degrees minus 60 is negative 120 degrees. And with negative 120 degrees, I can now take 2x equals negative 120 degrees, and then when I divide by 2, I'll get x equals negative 60. And that is a valid answer because it's between negative 90 and 90. Most people would not get this one right here, and so it's okay if you don't see it. I want to show it to you so that you could have an idea of what's there. And that's where the principal values are tricky, and if that happens on the test, I'll be gracious for you. Let's look at the next one. So we have sine x equals 1 plus cosine squared x, and here we want to solve, and this is where things get a little tricky. I'm going to pause real quick and work it out so that you'll see it instead of me rambling on as I do it, and I'll go slow with you. Alright, so I want to make sure that I put it in order and I could go through one time, because once you see this, then you should be able to recognize it later on. But when you're doing trig identities and we have multiple things, you're looking for trig identities that gets you to one equation, especially you notice when you see the squared here, because in this problem, I'll show you what happens. On the bottom here, we factor it, and this sine x squared x plus sine x minus 2, you might recognize it better if I just write x squared plus x minus 2 equals 0, and if I were to factor that, you can see x minus or x plus 2 and x minus 1 is the factored form, and that's what we're really getting to. So I want to show you the end of this before we step through it. So coming back to here, when you see the sine x equals 1 plus cosine squared x, there's no identity that I have to change sine x, so I'll look at my cosine squared x, and then you remember that, oh, cosine squared x plus sine squared x equals 1. And so I could solve for cosine squared x, it's 1 minus sine squared x, plug that in, and then the right side of the equation, 1 plus 1 is 2, and there's my negative sine squared x. I then moved everything over to the left side to get sine squared x plus the original sine x minus 2, moving the 2 over, it equals 0, and then I factor it, and then I'm here. And again, we're in the principal value section, so we'll see if both of these work. But if I set this equal to 0, and solve, you can see sine x equals negative 2. If I set this one equal to 0, you can see sine x equals 1. Okay, and so we got to remember that this is opposite over hypotenuse. So one of these actually doesn't work. The one that doesn't work, if you look at it, you see negative 2 here. That's impossible. It's not something that can work for us. So this is the only solution, because I can't have a fraction with the hypotenuse on the bottom that the opposite side would be bigger. That's the only way you could get negative 2. And so I look at sine equals 1, and then at that point you could use your calculator if you need to, but remember sine goes with a y, and on a unit circle that's at 90 degrees. So the answer to 22 is that this will only work when x equals 90 degrees. And that will happen, what could happen here on when I factor out, it either doesn't work or it does work, and then the question is, does it work for the principal values? And so you'll do more, and you'll see it come up. Okay, I'm going to make some room and get ready for the next problem. Okay, so now we have 24 cosine x times tangent x equals 1/2. We're only dealing with x between 0 and 360. So we actually solve for x, and then we'll just double check where we're at. So here we're looking at these two, and hopefully this one is straightforward for you, and you remember that tangent x has to be equal to sine x over cosine x. So this just becomes cosine x times sine x over cosine x equals 1/2. The cosines cancel out, and we're actually asking, when does sine x equals 1/2? And again, you're looking at a value for x. This could be anywhere in the circle, so that's opposite over hypotenuse. So we're looking for positive 1 over 2, or over here positive 1 over 2. And you recognize that as a 1 to root 3 triangle. That would be negative root 3, and that would be positive root 3. It doesn't matter if it's positive or negative, because we're really just looking at the angles. And then across from 1, hopefully you recognize that as a 30-degree angle. If not, on your calculator, you could take the inverse of both sides and do this. And what you'll do is you'll get that 30 degrees. Well, that 30 degrees is also this 30 degrees. And so that means that this angle right here, from 0 to here, has to be 150 degrees. And so the answer for x will be equal to 30 degrees or 150 degrees. Okay, and again, you could pause and go back, so I'm just going to keep going, but I'm going to pause and get ready for number 26. Okay, number 26 looks ugly, but it's really not. One trick that you might do is, since everything is cosine here, really this is asking you to take 2x squared plus 3x minus 2 equals 0 and factor. So again, when you're doing solving using trig identities and stuff, these are just common tricks that you have. So this one, everything's already in cosine, so I'm not looking for an identity there. But I do need to get it to a point where I can solve and look at the ratios to figure out the angle. But hopefully you notice that this and this is like doing x squared and 3x. So if this is easier for you to look at right here, you could do it this way. You're going to have two numbers that multiply to get negative 2, so I'm just going to go and make this one negative 1 and this one plus 2. And then I also have to use another 2 and a 1, but then I have to subtract to get 3. So I could look at, well, let's see, 2 times 2 is 4, 1 times 1 minus that would be at 3. So I want the 2's to be positive. Now, I could have chosen the negative here and then I have to redo it. But I could test this. 2x times x equals 2x squared. 2x times 2 is 4x minus 1x is 3x, and then negative 1 times 2 is here. So I guessed right on that first attempt. If I didn't do it, I would just have to rewrite this until I get the right factor. But what happens is this is the same thing I go over here. So instead of x, I write cosine. So I got 2 cosine x minus 1 times cosine x plus 2. That equals 0. So you don't have to do this over here. I just wanted to show you that if you're struggling with looking at all these trig functions and remembering how to factor, you could replace the same trig functions with a variable and then solve from there. So what this is really saying is either this is 0 or this is 0, or both. And so we're going to find out what happens when this is 0. Well, I'm going to add 1 and divide by 2. So cosine x equals 1/2. When this is 0, I just subtract 2. So I have cosine x equals negative 2. Now, like before, is this possible right here? It's not, because on your triangle, it's adjacent over hypotenuse, and what this would, in order to do this, that means that adjacent side, it has to be bigger than the hypotenuse. So that's impossible. It doesn't work. So there's no way that this is 0. The only time is when we get this to be equal to 0. So we don't have to worry about the other one, we just worry about this. And let's go ahead and on our bow tie graphs, when do we have cosine 1 over 2? Well, we have it here, be 1 over 2, and then we also have it here, 1 over 2. And so we got this angle, and we also have this angle right here. Now the nice thing is that they're still dealing with our special triangles. And we have a 1, 2, root 3. By now, hopefully, you recognize that across from the 1 is the 30. Across from the root 3 is the 60. So what I have is I have 60 degrees here. And then I also have 60 degrees here. But this will be 60 degrees. And this will be 300 degrees. Because I got to go all the way around. And they remember they want us between 0 and 360. So I can't write it negative. But I could write x equals 60 degrees or 300 degrees as my answer. Again, if you need to go back and see that, or just keep going, and you'll get more and more of these as we practice. There's odd questions there for you to get some extra practice as well. So looks like I'm not pausing to get to here. So this one's already set up for us. The only difference is they want us to work in radians. And what I do is if you struggle with radians right out of the start, do it in degrees and then convert. But this one is just saying, hey, it's already set up for us, so 2 sine x minus 1 has to be equal to 0. So 2 sine x minus 1, I got to add 1 to both sides, divide by 2. So you would have sine x equals 1/2. Here, I would add 1, divide by 2. I have cosine squared x equals 1/2. So I can take the square root of this, and I'll get cosine x equals the square root of 1/2. Excuse me. Sorry, I had to cough there. Now, problem with this one is when you take the square root of something, you have plus or minus. So on this problem, instead of, you'll have extra things to solve for. Let's go ahead and focus right on the sine x though first. I'll change this to blue. So we're looking for angles where sine x equals 1/2. Well, that's adjacent or opposite over hypotenuse. So we're looking at that angle where it's 1. We're also looking at this angle over here where it's 1, 2. And again, you hopefully recognize that as a 1, 2, root 3 triangle. And with that, across from the 1 is 30 degrees, so that's 30 degrees. And this is 30 degrees. And so we're really talking about 30 degrees and 150 degrees. But we're supposed to be in radians, so we'd want to convert to radians. And just to do it, if you're sitting there going like, you get nervous, just do the simple conversion here. You don't have to try to have it memorized. Just 30 degrees here, 30 goes into 180 6 times, so you're going to be left with pi over 6. 30 degrees, or 150, excuse me, and 180. Okay, so 30 goes into this 5 times, it goes into this 6 times, and then you're left with 5 pi over 6. So far I'm going to go ahead and write our answer here. We have x equals pi over 6 and 5 pi over 6, but we still have to look at the cosine. If we look at the cosine, we got a problem, because we got to look at a bunch of cosines, because if we want to focus, let's focus first on the plus 1 over square root 2. And so this has the hypotenuse as a square root of 2. You could also rationalize the denominator right here. Excuse me, it's the square root of 1, or 1 over square root 2. Oh, we're fine right now. Okay, so if it's positive, it would be here, and the other positive would be down here. Okay, and so we have 1 over root 2. Hold on a second. All right, I needed a second because I had my head wrapped around 30, 60, 90, and 1 over root 2, hopefully you recognize as a 45-degree angle. So not root 3, root 2. So 1 root 2, and this would be a 1 as well. And then you have negative 1 here and root 2 here. I keep on writing that 3. Okay, so this you'd see as a 45-degree angle, which is the same thing as pi over 4. Now what we have to do is we have to get the 45-degree angle here, and since they're all cut in half, let's go ahead and do that, where we got 1, 2, 3, 4, 5, 6, 7. So this would be 7 pi over 4. And then so our next two answers would be pi over 4 and 7 pi over 4. But we're not done yet, because we dealt with the positive 1 over root 2. We now have the possibility of a cosine x equals negative 1 over root 2. And remember, the hypotenuse is always positive, so whenever you have a negative, put it on the opposite or adjacent side. So this is going to be in this quadrant, but we've already done most of the work, so it's a little bit easier. This is 1, negative 1, here's my root 2, here's my root 2. And so I'm talking about these two angles. I'm talking about this angle here, and I'm talking about this angle here. We know that this is 45 degrees and this is 45 degrees. So if we just count them, here's 1, 2, 3, so that'd be 3 pi over 4. I'm counting the pi's over 4. There's 4 pi over 4, and this is 5 pi over 4. And so if I add that to my answer block here, I can see how I have a lot of answers. Remember, a lot of times our homework is harder than the test, so don't stress too much about whether you would be able to get all 6 answers here or not. If you could follow along what I'm doing, that's what's important at this point. Alright, let's look at 32. I'm going to pause it and make it look a little prettier for you. Okay, there's one little mistake here. This is an equal sign, not a minus. So we have root 2 tangent x equals sine 2 sine x. And then you look at that and go, well, what am I supposed to do with that? Well, let's work it out a little bit. Let's see what simplifies for us. We know that root 2 is root 2 sine x over cosine x, because that's what tangent equals 2 sine x. And then if you just divide both sides by sine x, you can see that sine x cancels out, and we got root 2 over cosine x will be equal to 2. And then if you multiply both sides by cosine x, you see how root 2 equals 2 cosine x. And then divide both sides by 2, and you can see that cosine x equals root 2 over 2. Okay, so now there's a trick though on this one. I'm sorry I picked all the problems that have tricks. One that that would be really hard for anybody to notice. So this works here, but let's come back and look at this, because there is kind of a trick. Can I make this and this 0 at the same time? Because when I looked at this right here, there is an answer, because here's my answer is only in cosine. But if I look at this and this, there's a point where sine x and sine x can both be 0. When is that? Well, my unit circle, remember, it goes with the y, so I have a 0 here and a 0 here. So at 0 degrees, tangent is 0 because it's 0 over 1, and sine is 0 because it's just 0. And at 180. And then root 2 times 0 is 0, and 2 times 0 is 0. So x, just by looking at it, 0 and 180, and 180 is pi. And so 0 and pi, because remember we're supposed to be in pi's, are two answers just based on the sign. That disappeared when I divided both sides by sine, and I almost missed that. But those are my first two answers. Now let's go back to cosine x here. When you see the root 2, hopefully you recognize that as a 45-degree triangle. If you don't, we can get here and we can say that, okay, the adjacent side's root 2 over 2, and we come up here and root 2 over 2. And if I were to divide everything by root 2, things would cancel out, and you'd see that this is a 45-degree angle here. Just look at 2 divided by root 2, you rationalize the denominator, and you get 2 root 2 over 2, cancels out, you get root 2, and then you can see how you have a 1, 1 root 2 triangle. So there's pi over 4, and remember we went 1, 2, 3, 4, 5, 6, 7, that's 7 pi over 4, and that's our two other answers. Pi over 4 and 7 pi over 4. Ah, my computer is not being nice to me. Or maybe I'm doing it somehow. Go a little bit slower. Okay, I'm going to make the other one pretty for you. Okay, so this one looks a little fun to do. We have cotangent squared, we have cosecant squared. Now on here, there is a trig identity with cotangent that has cosecant in that. And so why don't we pause and find that. Okay, took me a couple seconds to find it, but to you it's immediate. But if you go to page 423, if you have your book in front of you, or if you have your notes, you may remember seeing 1 plus cotangent squared x equals cosecant squared x. And so I could have looked at that and went cosine over sine, and then this cosecant is 1 over sine, and then I could try multiplying and do some things to get close to the same, or to get it in terms of sine and cosine, and I might be able to work it out. But when I look at this right here, I go, well, can I change my cotangent to, or can I subtract 1 on both sides here, and I get this problem. So this is cotangent. So then if I could convert that into here, I really have cosecant squared x minus 1, and then minus, that's my cotangent, minus cosecant x equals 1. And then so I could then go cosecant squared x minus cosecant x, and then if I subtract this over, I got minus 2, and that's equal to 0. And then like we had before, you can think of this as x squared minus x minus 2, x squared minus x minus 2. And can you factor that? You're going to have x times x, and then negative 2 times plus 1, because I got to make sure that the plus 1, that the 1 is the smaller, is the positive, because that's negative right there. And so I could come back to my problem and say, well, this is going to factor into cosecant x plus 1, which is now solvable, and cosecant x minus 2, which is also solvable. So here, if this is equal to 0, I have cosecant x equals negative 1, and here I have cosecant x equals 2. You might think, oh, those are impossible because they're whole numbers, but remember, it's 1 over. So this is really 1 over sine x equals negative 1, and this is 1 over sine x equals 2. In other words, I have sine x, now the reciprocal of negative 1 is negative 1, so that's fine. And here, sine x will be equal to 1/2. I just take the reciprocal of both sides. Both of these are solvable. This one is the easy one, because when is sine negative 1? Well, that's when it's pointing straight down on my unit circle. Remember, sine goes with the y, so that means it's the angle that goes to here. That's 270 degrees, or that's pi over 2 pi, and then 3 pi over 2. So I have 3 pi over 2 as one of my answers for x. Hopefully you are able to follow that. I just did it quickly in my head trying to find the radian measure. Alright. Then what I can do is I can look at sine 1/2 and sine 1/2. There's two possible places for that. I have sine 1/2 right here, so that's 1, 2. And then I also have sine 1/2 right here, 1, 2. And then that's a 1, 2, root 3 triangle. And across from the 1 is my 30 degrees. So I can look at that and say, well, that's 30, and this is 150. And from previous problems, we recognized those as pi over 6 and 5 pi over 6. I'll just write that here. Pi over 6 and 5 pi over 6. And if you remember, I told you memorize these and review them. Hopefully you did, and hopefully that's a lot easier for you. Alright, we got 2 more problems to look at. 3 more problems to look at. My mistake. And let me make it prettier for you. Alright. Back here, now again we have, let's see, we have cosine tangent x minus 2 cosine squared x equals 1. At first you might think, well, can I get it? Can I factor the cosine out? And that's possible. Actually, let's try that. Let's see what happens. Whether this works or not, it's a good practice to try different things and see what happens. Here I have cosine x tangent x minus 2 cosine x equals negative 1. That really doesn't help me at all. And so I might, this is sine over cosine, and then I could try to combine and then do something with that, but it's just going to make it uglier. And I like to not erase when I take a step that I shouldn't have done, just in case I come and I realize, oh, I should have done that before. I don't want to make it too ugly there. So then I look at cosine and tangent x again. I go, well, I could have canceled out the cosines. That has to do with tangent, because I have sine x over cosine x. That's my cosine x tangent x. And I have minus 2 cosine x equals negative 1. And so if you notice, these cancel out. And now I have sine x minus 2 cosine squared x equals negative 1. And at this point, this should remind you of a similar problem that we had before, where cosine squared x plus sine squared equals 1. So you solved for that, and you're able to take the cosine squared x and go 1 minus sine squared x. And all that was just to get this into terms of sine x so that we can factor using our algebra. So again, ugly problem, and what I'm going to show you is if you go on the wrong step, just start over. These are not easy to do, and you will make mistakes on here, and if you have extra time on the test, redo some problems to see if you get a different answer. So let me double check I distribute it. Negative 2 times 1 is negative 2. Negative 2 times negative sine squared x is positive. And so let's go ahead and get everything on the left side and put it in order. And then if I add 1 over, this would be minus 1. So equal to 0. And if I'm going to factor that, it's going to be on here. I could have, in order to get 1, it's plus 1 minus 1. It's positive, so I want the 2 sine to be here, and this will be sine x. Okay, and then so now I need to set these equal to 0. Subtract 1. I got sine x equals negative 1, and I got sine x equals, that becomes positive 1 over 2, so 1/2. And the negative 1, just like we did before, see, solve each equation for all real values of x. Let's go ahead and do these in degrees. I think the book has them in radians in this section. I'm going to go ahead and stick to degrees. Remember, sine x negative 1 is 270. Now that's not my answer because we're looking at all real values, and we'll get to that. Here, sine 1/2, remember, is 1 over 1, 2 here, or 1, 2 here. And we've done this problem a bunch of times. That was the 30 degrees, that was the 150. But we got to be careful now, because here I'll write the answer. X equals, now I could write 30 degrees, but it's any 30 degree angle, so I write 360 times k. I could write 150 degrees, but it's all real answers, so I got to go 360 degrees times k, and likewise 270. Now it gets tricky when you have things that are 180 degrees away, because then you'll have less answers, but x could be all those answers. And so that's when we look at and see if you have all real values. You got to get the k in there. People get that wrong all the time, and so you got to make sure you notice that. Okay, another good problem is cosine squared x minus sine squared x. And here you just want to double check that that's not a half angle identity. So I'm actually going back in my book, and no, it's 2 cosine squared x minus sine squared x. I mean, it's cosine squared x minus sine squared is a half angle identity, so we can't use that. But let's go ahead and turn one of these into the other. I'm not sure which one to do. I'm just going to guess. So I'm going to keep the 2 cosine because I don't want to have to factor out that 2. And so I'm going to subtract, and this is going to be 1 minus cosine squared x. And that'll be equal to root 3 over 2. And so if I factor that through, 2 cosine squared x minus 1 plus cosine squared x equals root 3 over 2. So 2 cosine squared x plus cosine squared x is cosine squared x, and that has to be equal to root 3 over 2 plus 1. I'm going to pause here and double check that I didn't do something wrong. So hold on. Okay, what threw me off here, because I was going, hey, this is bigger than 1 and cosine can't be bigger than 1, but then I realized, oh, we're dealing with cosine squared here, so we're okay. So let's go ahead and keep going here. You could plug this into your calculator, but I wouldn't. I would just do 2 over 2, and so you're going to get root 3 plus 2 over 2. And then we're going to go ahead and take the square root of both sides. So we have cosine x equals, and this looks really ugly, we have root 3 plus 2 over 2. So we have the square root of that. Okay, I can't go change the video, but I don't know if you caught my mistake here. But 2 plus 1 is not 1, it is 3. 2 cosine squared x plus cosine squared x is 3, so cosine squared x. So I have to come back here. I noticed something was a little fishy with that, and so I was trying to figure out what I did wrong. So again, 2, and that I should have a 3 right there. And so now I'm going to have cosine squared x equals root 3 over 6. And so stop there for a minute, and then I want to make sure that I don't make another mistake. Okay, I did make another mistake, but my mistake was actually I wrote down the wrong problem here. And so this problem is not possible. I was like, where did it go? And if you look in your books, I have no idea what I did. Oh, here's what I did. I combined 40 and 44. And so 40 is not this right here. 40 has 2 cosine squared x equals 3 sine x. Much easier problem because the other problem was impossible. Okay, so here, let's just start over on this problem right here. I think now, since we have cosine squared x and sine, we're going to go 1 minus sine squared x equals 3 sine x. And then this is going to be 2 minus 2 sine squared x equals 3 sine x. Since everything on the right side will be positive, let's move this over to the right side. So add 2, that would give me 5 sine x. And then I'll leave the 2 over there. Oh, sine squared x. Oh, no. I'm so flustered right now. I can't believe I keep doing this. Okay, so that is sine x. I thought for a second it was squared. So let's stop right here. Let's go back over it. So 2 cosine squared x equals 3 sine x. I changed cosine squared x to 1 minus sine squared x. It equals 3 sine x. I factored the 2 through, and then I didn't change that. I almost made it a squared. I'm still going to move everything to the right side. So the add 2 sine squared x over. Then I got the plus 3 sine x, and then I subtract the 2 over. So I'm right here, and I got 0. And then again, this is like 2x squared plus 3x minus 2. So we want to factor that. And don't you just love algebra 2 factoring? And so let's say I'll start with just doing my 2 sine x here and my sine x here. Now the two numbers have to, let's see there, I got a negative and a positive. And so if I go 2 times 2 is positive 4 minus 1, I'll get to my 3. So 2 times 2, and that has to be positive. So there's my 4 sine x. Here's my minus 1, and negative 1 times 2 is negative 2. If you didn't follow that, that's okay. What you want to be able to do is take 2x squared plus 3x minus 2 and factor it. There's different methods to factoring. You have to have one that's comfortable for you to do. So here we have sine x equals 1/2, and this is sine x equals negative 2. Which one of these is impossible? Give you 2 seconds. 1, 2. It's this one, not possible, because it's bigger than 1. So we're only looking where sine x equals 1/2 and sine x equals 1/2 here or here. So 1/2, 1/2, and that's our famous √3. And so we know we're at not 50 degrees, 30 degrees. And we're now at 150 degrees. I think this is the section that the book had everything in pies. I'm just going to keep it in degrees. So we know we're at 30 degrees plus 360 times k, and 150 degrees plus 360 times k for all the possible values, all real numbers. All right, we're almost done. We got one more problem to look at, and that is, what about inequalities? We're not going to spend a lot of time on inequalities. And don't look at that because I misspelled it. Couldn't tell when I was typing in early before, but inequalities, not inequalities. That's kind of funny. Solve the inequality for theta between 0 and 2 pi, so between 0 and 360 degrees. So what this means is we have cosine theta. If we add 1/2 to both sides, we get, when is it bigger than 1/2? And this is 50, but again, page 460. Well, let's find out when it's equal to. So on these problems, figure out where it's equal to 1/2. And again, we have, it's between 0 and 2 pi, so we have two possible locations. We have 1/2 here, and we have 1/2 here. So we have this angle, and then we have all the way around. Okay, so that's a 1, 2, √3. Now, across from 1 is 30 here, so this has to be the 60-degree angle. So that's 60 degrees. That means that this is also 60 degrees in that triangle, so that would be 300 degrees. Okay, now I'm going to stop here. You might want to I'm going to ask, be ready to hit the pause button, because what we found out is when it equals 1/2. And now I want you to try to think through this. What happens as I go around the circle? Think about where cosine theta comes from. It starts at 0 and goes to this point, and then it goes up to here. Okay? So I'm going to pause right there. See if you can figure out. It's going to be, since it's an equality, it's going to be a range of values. So stop right there, or pause before I give you the answer. Okay, so hopefully I didn't give you too much of a hint there, but like I said, it starts at 0, and we know it goes up, so cosine theta being bigger than 1/2, if cosine theta is bigger than 1/2, then when it gets to 60 degrees, and I'll go ahead and stay in radians, so it starts at 0, or at 0 degrees it starts at 0, and then when it goes to 60 degrees, that's when it's 1/2. So between, excuse me, I was thinking sine. Almost made a mistake there. Cosine starts with 1 here, and then as it goes up, it goes to 0 for the x value. So at 0, it starts at 1, and then it gets to 1/2 when it gets to 60 degrees. And then when it gets to 90 degrees, cosine becomes 0. And then after that, from 90 to 270 degrees, it's negative. That's when it's on this side. So you'll always have a negative cosine value, so it can't be bigger than 1/2. And then it goes cosine to 300 degrees, but it goes at 270, it's also 0, so it's 0 here, and then as it goes to 300, when it gets to 300, it's 1/2, and then from 300 to 360, that's when it goes back to 1. So my range where cosine is bigger than 1/2 is right here and right here. And so in degrees, you would say that theta is between 0 degrees and 60 degrees. Actually, it's equal to here because at 0 degrees it works because it's 1, and that means it's bigger than 1/2. But at 60 degrees it's equal to 1/2, and since they gave us an equality of greater, you can't make it equal. And then we have the answer to of 300 degrees, and it can't be equal to it, so we would write greater or less than, and then we're here. Okay, and then if they want you to convert to radians, you could convert that to radians. That would be pi over 60 goes into 183 times, and so 300 degrees is 5 pi over 3, and you can figure that out if you need to, and then 2 pi. So this is what the book would have as the answer. This is what I did just to keep it in degrees. And again, this is the end. If you made it this far and didn't fall asleep, great. I hope that you study this and just keep trying. It's really easy to make mistakes. I show that myself. Just do your best and keep plugging away. What you learn from here, just doing the problems is what's most important than always getting the right answers.